Hello everyone, myself Kirtana. Today we are going to study one of the core concepts of computer organization, which is processor design and pipelining. This topic helps us understand how a processor works internally, how instructions are executed, and then how performance is improved using modern techniques like pipelining. Next, we move to the processor design. Processor design refers to the internal structure of a CPU. It defines how different components such as registers, ALU, control unit, and memory are connected and how they work together to execute instructions. The processor mainly consists of data path, which performs operations, control unit, and which controls the flow of data and instructions. And the next slide is data path components. The data path is responsible for data processing. Its major components are program counter, instruction memory, register file, ALU, data memory, and then control unit. Program counter is used to hold the address of the next instruction. Instruction memory stores program instruction. Register file store temporary data. ALU performs arithmetic and logical operations. Data memory stores the data values and then control unit generate control signals. Together, these components allow the processor to execute instructions efficiently. Next, we move to the slide instruction execution cycle. Every instruction follows a fixed sequence known as the instruction execution cycle. It consists of 5 stages. Instruction fetch. Instruction is fetched from memory and then instruction decode. Instruction is decoded and the operands are read. Execute. Operation is performed by the ALU. Memory access. Data is read or written to memory and the last one is write back. Result is returned back to the register. This cycle repeats for every instruction. Next, we move pipelining concept. Pipelining is a technique used to improve processor performance. Instead of executing one instruction at a time, multiple instructions are executed simultaneously in different stages. This is similar to an assembly line where each stage works on a different instruction. Then we look pipeline hazards. Pipeline hazards are situations that prevent the next instruction from executing properly. There are three types: structural hazards, resource conflicts, data hazards, data dependency between instruction, control hazards caused by branch instruction. Next, we move to data hazards. Data hazards occur when an instruction depends on the result of a previous instruction. To solve this, we use forwarding stalling. Forwarding means passing results directly. Stalling means delaying instruction execution. Then control hazards. Control hazards occur due to branch instruction. To solve this, we use branch prediction, delayed branching. These techniques help maintain smooth pipeline execution. Then we move to performance analysis. Pipelining significantly increases processor throughput. However, performance depends on number of pipeline stages, frequency of hazards, effectiveness of hazard handling techniques. In summary, processor design forms the foundation of CPU operations. The data path and control unit work together to execute instructions while pipelining improves execution speed. Proper handling of pipeline hazard is essential to ensure better performance. In the next sections, we will see practical examples and performance calculation. Thank you.